Hello and welcome to the New Year's Day edition of Cracking the Cryptic. I hope you all have had a very happy New Year and a very good evening celebrating last night. I'm feeling slightly delicate today. The less said about that, the better. And let's just hope it doesn't affect my ability to solve Sudoku. What have we got for you? Well, we've got a puzzle called Spokes by Crangoon. And I think this must be Crangoon's debut on the channel because I don't recognise the pseudonym. But the testers say this is a very beautiful and quite approachable puzzle for us. So that might bode well. I'll read you the rules in just a second. A few things to mention first though. The Pyramid Hunt, if you've been trying that, it is now finished. Over on Patreon, we have released an incredible 45 video series explaining how to solve all of those puzzles. Quite extraordinary. I will say that 42 of those videos came from the creators of The Hunt. So that's Panthera, Aspartagus and Peter Venus. Thank you so much to them. The amount of work they have put into this for our benefit, you know, the amount of hours of pleasure we've all got from that hunt over the last few weeks is it's a very big number, and a big thanks to them. I contributed just 3 videos, so if you want to know or watch me solve Ephidus is Rogan, the Pyramid Litz puzzle, or a few a few raindrops or something like that from Panthera, then you can watch those on Patreon as well. Now, speaking of Patreon, we have of course released January's reward today, which is, don't think I'm giving away too much by saying it is a Star Wars themed hunt by Peter C Hayward. And yeah, that went out at 4 o'clock, and I'll certainly read the names of any entries we get in it. Well, if we get any entries tomorrow, for example, you'll definitely get a shout out on the channel because that would be some incredible solving. Anyway, I hope you all enjoy that. That is there for you right now. Now, apart from that, what's going on? I am aware, many of you have already told me this, but I am aware that Fistemfell has 2 unsolved puzzles. When I say unsolved, I mean puzzles that I've not yet had a chance to do on the channel, over on Logic Masters Germany. I know Mark has looked at one of them, which is a puzzle called 7. In fact, I'll try and find it. 1 second. Yeah, so this is it. And yeah, Mark's had a look at it, and he's not sure actually whether it would make sense for me to do it in a channel video. I am not sure why, I have to say, but I do trust him, so I'm not sure what I'll do. What I might do is just record myself solving it, if I can solve it, on Patreon at some stage. But yeah, 6x6 grid and just a couple of little thermos, and something about different regions having to be, well, I'm not going to be able to read this quickly enough. Anyway, there's something going on there. Yeah, that's one of them, but there's another puzzle as well that he's released, and I want to have a look at that in due course too. Now, the other thing we've got going on is we released a YouTube short earlier on today on this new viral word game that I'm sure most of you are familiar with. It's all over our Twitter feed at the moment. It's called Wordle, and basically you have to... in fact, let me show you that as well. Hang on. Here we go. This is the game Wordle. It's an incredibly clever idea. Basically, all we have to do is guess whatever the 5-letter word is of the day. There's one puzzle a day. So in fact, let's do it. Let's just have a go. We'll guess at risen. And then, we've not done badly here. So then it tells you if you get a green letter, it means that letter is not only a correct letter, it's in the correct position in the word we're trying to find. A black letter has no place, doesn't appear anywhere in the correct solution, and a sort of gold letter is a correct letter but in the wrong place. So it's a bit like the old logic game Mastermind, if you ever played that. And yeah, so basically we now have to come up with the word, which is now going to be embarrassing if I can't do it. We get a few guesses to do it. Now, I quite like sometimes to do this. Let's do this and see if this helps us. You may wonder why I've ignored all of the letters I know about, but this has been a total disaster. I've been hoisted by my own petard. I thought this would be good, because if you use the words, well, siren and octal or risen and octal or something like that, you're actually covering the 10 most common letters in the English language in just those 2 words. So you normally get an awful lot of hits from those 10 letters. Now here, unfortunately, my second guess has proved rather fatally inaccurate. So let's actually try and do this seriously then for our next guess. So we'll have an R, which is in the correct position. It's probably a plural. So we've actually, it's actually quite interesting because, and this is why this game is clever. It's because it makes you think. If we assume this is a plural, it's not that easy to believe it doesn't have another vowel in it. And if it has another vowel in it, it can't be, unless it's a repeated E, I suppose. Oh, maybe it's or it could be, yeah, a word like ruses I'm quite interested in. Let's just see if we get anything from that. No. Oh, in fact, the ruses was and look, this is me being daft. Ruses is a silly guess. And this is why I shouldn't have done this on camera, but ruses is a silly guess because we know this E is in the wrong position. So I shouldn't have guessed ruses. So, but now I've got a U that's a correct. Oh, it's going to be something like, rebus, perhaps, which is at least that's a type of puzzle, which would be, yeah, wow, okay, that was tricky. So yeah, that's what you have to do. There you go. You can see I've played it before. I have a win streak of 2, and both times I've managed to get it in 4 guesses. And my next Wordle is available in 6 hours. So anyway, do have a look. It's very interesting. I'll try and remember to put a link under this video. I realise this is nothing to do with Sudoku, but I know a lot of you like puzzles, and this is a puzzle I think I will probably add to my daily puzzle regime. Anyway, I should stop wittering on, and let's get on with spokes now. So what are the rules? We have got normal Sudoku rules apply. In cages, digits must sum to the small clue in the top left corner of the cage. Okay, and all of the cages are in their boxes, so we don't need any stipulation about there not being a repeated digit in a cage, because there simply cannot be a repeated digit in a cage without breaking the rules of Sudoku. And digits on grey lines form palindromes, i.e. they must read the same forwards and backwards, e.g. 13731. So yeah, so if this is a palindrome, then let's imagine this cell was a 1. Because this needs to read the same forwards and backwards, so this digit and this digit will have to be the same. So if that's a 2, that has to be a 2, and then this digit actually is completely optional. It can be anything at all apart from 1 and 2 because of the rules of Sudoku. So let's put 4 in there, and now if we read it from this side, 1, 2, 4, 2, 1, and if we read it from the other side, 1, 2, 4, 2, 1, you can see it reads the same in both directions, and that's what we're looking for. Do have a go at the puzzle. The way to play is to click the link under the video. Now I get to play. Let's get cracking. Now, I know you all want me to do Fistemafel. I'm sort of very tempted to dive into Fistemafel whenever I see 2x2s in the corners. That is always very... If you're not familiar with Fistemafel, by the way, there is a theorem which basically states that these orange cells in any Sudoku puzzle, this applies by the way, these orange cells in the corners, there are 16 digits there, are the exact 16 digits you will find in that blue ring. It's discovered by the genius Fistemafel, and that's why it's called the Fistemafel ring. But look, I'm not going to just dive in there and do that. Let's actually just try and see whether there's anything else we can do without jumping into geometry. We can actually, I'm not seeing much at all I can do without jumping into geometry. So perhaps 15. No, actually, I'm wrong, I think. Yeah, this is quite interesting. Let's look at this, rather than looking at the whole Fistmafell ring, let's just look at this 2x2 down here. This might apply across the grid though. Yeah, because look how interesting this palindrome is now. So the question I want to ask is, where do these orange cells go in column 3? Now, they obviously, anything that's in these orange cells can't go in those 3 cells because it will definitely clash in box 7. But also, it can't go in these 2 cells either, because if there was an orange cell in one of these 2 cells, then because of the palindrome, that would get reflected onto this domino and it would clash again in box 7. So these 4 cells in column 3 have to be those top cells there, which is quite intriguing. And that is what? That's really clever. Right, okay, I don't need geometry, or I need shortened form geometry, because now the only other thing about this puzzle that struck me when I first looked at it, as regards these 2x2s in the corners, is that they are all fairly low totals. You know, the maximum we can make 4 digits add up to is 30. The minimum is 10, so you can see that 14s and 15s are much closer to the smaller boundary than the upper boundary. But now, if I've got, yeah, I mean, if these squares add up to 15, and they do, then we can use the secret, and I can get a digit. I can get this digit, because the secret, and this is something I only tell my favourite people, but it's a new year, and I'm absolutely sure you're one of my favourite people, is that in any complete row, in any complete column, or in any complete box of a Sudoku, if you add up the digits that you get in the completed solution, you will get the number 45, because it's the digits 1 to 9 once each. So I know that those cells there add up to 45. But I also know, because of the fact that orange adds to 15, and blue, these blue cells here add up to 14, that those cells add up to 29. Well, given I know the whole box adds to 45, I've got to make this a tiny digit, because I can't make those two more than an 8-9 pair. So if I made these as much as I could, then these 10 cells would now add up to 46. That's the absolute most I can make them add up to. So this square here has to be a 1. I'm just going to double it. No, that is right. My maths is right. That is right. So this has to be a 1. And this has to be an 8-9 pair. Otherwise, maths doesn't work. And I have found in life that maths does tend to work. So that might be interesting, because now presumably we can just repeat this trick around the grid, can't we? So again, if I ask where these digits go in row 3, they have to go in those squares. And now we get this exactly the same equation again. It works exactly the same way. And it's going to go round the grid. This is lovely. It is like a wheel. So yeah, but because these add up to 14, plus 14 plus 15 is 29. If I max these squares out with an 8-9 pair, I'll get to 46, which means this has to be 1 in order for the box to add up to 45. It's the only way it'll work. And now we just carry on doing this, don't we? These squares at the bottom have to be the same digits, therefore these 4 squares add up to 15, that's 14, that's 29, these have to be an 8-9 pair, this square here has to be a 1, 14 here, so let's just complete the ring. Actually I don't want to use red because the red's very close to orange, I'll use purple instead. So these are 14 plus 15 is 29, this must be an 8-9 pair, this must be a 1. We've got 4 1s looking at the middle box. The central square of the grid is a 1, and we are off and running. And now that's really very clever. That's really very clever, and I'm quite pleased in a way that we didn't have to use Fistamafel. Now, look, now we've got palindrome things going on, because look, we've got 8s and 9s. Oh, we've got loads of 8s and 9s that are sitting on palindromes. So let's proliferate our palindromes, and what should we do next? We shall say that that's got to be an 8 or a 9 as well. I'm quite tempted to colour these. Maybe that's a sensible idea, is it? I'm not sure. I've already got quite a lot of colour in my grid, but I'm thinking that, I know that these two, whatever they are, let's make them grey. And that one has to be different. Or no, a better one to work with would be this one has to be different. So those two are the same because they're on a palindrome. Now this one has to be grey. This one has to be yellow. Oh, okay, I was thinking that might go further than that, but apparently not. 22. Oh, can we use maths on the middle box actually? Let me just think about that. Yes, we can. We've got an 8-9 pair, that's 17. 17 plus 22 is 39. The whole box adds to 45, so these two squares add up to 6 and they can't use a 1. So that's a 2-4 pair. Do you need to put... you don't. Oh, bobbins. I was thinking, do you need to put an 8 or a 9 in an 18 cage? And you don't, because you could do it with 765. But we've got a 9... that's better. Right, we've got a 19 cage as well. Right, we can't make 19 without using an 8 or a 9. Oh, this is gorgeous. That's got to be yellow. Because 7 plus 6 plus 5 is only 18. So there must be an 8 or a 9 in that 19 cage. It's not a grey 8-9, so it must be a yellow one. And we've got yellow looking at that cell and yellow. Oh, that's an advert for Sven's SUDOKU pad. Definitely get it. It's brilliant. But I didn't mean to click on it. Look, so this square here has to be yellow. And that means... Oh, right, now look. Now we've disambiguated the 8-9s in the middle box. That's got to be grey. That's got to be grey. That's got to be yellow. That's got to be yellow. That's got to be grey. That's got to be grey. Does this keep going? Yeah, maybe it does. Those two are both yellow. Yeah, there are 4 yellows now, looking at box 2. So that's got to be yellow. And we've done all the yellows. Can we do 1, 2, 3, 4, 5? Yes. Well, I think we can do all of the greys as well. That's got to be grey. So there is an 8 or a 9 in the 18 cage, even though there didn't need to be. And now, oh no, okay, sorry, I was thinking maybe I could do something with the 15, but I don't think I can. The fact there's no 1 in it is almost very interesting, but it doesn't have to be. I don't think there doesn't have to be a 2 in there. We could do it with 3, 4 and 8, so perhaps that's not where we look next. Okay, a 13. Yeah, here's. Oh, this is great. Yeah, 13. You can't put 9 in here because a 9 will require a 1, and we've already got a 1 in the box. So yellow. Oh, whoopsie. Yellow is 8 by force, and therefore grey is 9. This 13 cage must have a 2, 3 in it because it can't have a 1, 4 in it to make up the balance. And all of a sudden, we've got a whole boatload of digits in the grid. And I'm just trying to see if I can spot what the natural... right, okay, well my 15 cage now needs 6 more without using a 1. So that's a 2, 4 pair. So there's now got 2, 4 pairs Or, well, we've got a 2-4 pair affecting row 4, which is maybe interesting. I don't know. I mean, do I really want to notate all of this with 3, 5, 6 and 7? I don't really want to. Or can we somehow learn more about these 2x2s in the corners? I'm noticing the pattern of 1s is a little bit interesting. This sort of wagon wheel of 1s is always pushing 1s into the corner boxes. Yeah, and we could have got that from Fistemafel, but that I don't have to prove Fistemafel to observe that, which is quite nice. So there is always a 1 in one of these low cages in the 2x2s in the corners, just because of Sudoku. 2, 3. Yeah, okay, and here's something quite cute. You've got to be quite careful with where 2 and 3 go in box 1, because you can't put them both in the blue cells, because if you do, it'll have to be a 1, 2, 3, 8 cage, and that will repeat 8 in the box. And you can't put 2 and 3 on the orange line, because once you put them in that domino, they get reflected into their own box again, and they'll clash in box 2. So that means there is exactly 1, 2 or 3 in the 14 cage, and there must be another one hidden away on the sort of crook on the elbow of the 5-cell palindrome. And that doesn't do anything. 2, 4. Oh no, right, simpler, much easier than this point. Look, where does 2 go in box 4? The answer is it doesn't go in the 19 cage, because if it does, you've got to put 9 in that cage as well, and you can't. So 2 has to be on this domino, and therefore reflects there into this cage, which puts a bit of pressure on that 15 cage, but more importantly, it gives us this digit. So that's a 3. There's now a 3 in that 15 cage. Now there is definitely a 2 in the 14 cage, because again we can't put 2 here without reflecting it there. So the 14 cage is 1, 2, 5. No, it's not. Okay, I still don't know what it is actually. That's a bit annoying. Oh look, this is lovely though. Yeah, I love this. This is really clever stuff. Now we can ask where 2 goes in row 3 of the grid. It can't go there, and it can't go here, or it reflects on that palindrome and hits the 15, the 2 that's appearing in the 15 thing. So there must be a 2 there. So now there's a 2 in this 14 cage. Nearly. Well, the thing I was noticing is there can't be a 4 in this 14 cage now, because then you couldn't put a 4 anywhere in column 7. And you can't put a 3 in the 14 cage, because then you'll need an 8 in it. So this 14 cage, that's beautiful. That is really clever. There's no 3 in it. There's no 4 in it. So there must be a 5 and 6 in it. That is a 1, 2, 5, 6 quadruple. Therefore, we know these squares out of nowhere. They've got to be 3, 4 and 7. And therefore, these 2 squares on the palindrome are also 3, 4 and 7. These squares are a 5, 6 pair to complete column 7. Therefore, those squares are a 3, 7 pair, which means that's a 3 or a 7 through the medium of palindromes. And over here, these squares are 2, 5 and 6. And that's not 2. And therefore, by hook or by crook, we are going to be able to know what's in this 15 cage now. We've got to put 1, 3, 4 and 7 into it, and that does indeed add up to 15. So that seems quite sensible. Okay. And now for our next trick, we will say that I don't know. I don't know what we're going to do next. Hopefully something. Can you put 3 in that 19 cage now? No, because then it'll need another 8 in it. So 3 is in this domino, which unfortunately isn't useful. Or is it? If there was a 3, yeah, no, it is useful because you can't put 3 here, because then it gets reflected in the 14 cage, which will then be a 1, 2, 3, 8 cage. So we get the 3. 3's got to go there. There's no 3 down here. 1, 4, 7. Okay, so can we now 4? If there was a 4 in there, it would have to accompany a 7. I suppose those squares are now 2s, 5s and 6s. Sorry, using the purple palindrome. I must try and keep track. Yeah, look, I've missed the palindrome here as well. Those have to be a 5, 6 pair. That's huge, because that means those have to be a 4, 7 pair, which means oh look, it's all done. This is a 4, 7 pair. So now this 14 cage must be a 1, 2, 5, 6 cage, like its friend down here. So these were the same. Okay, and therefore this is getting reflected here. So that's not a 1. This is a 2, 5 or 6. Oh, that's beautiful. That gives me a 2, 5, 6 triple in box 4. We know that one's not a 2. Therefore we know that one's not a 2, because we know there's a 2 in this domino. And now we must be able to put 4 and 7 into my 18 cage. And that's rather lovely with this 3-7 combo here, because that gets me another digit. That's a 4. That's a 7. I now get a 1-4 pair at the bottom of the grid, a 3-7 pair here. This 4 is looking at the 4-2 in the middle, so we can do those. This square is no longer 2, so that one is a 2. And this has got to be a 5 or a 6. And oh, we've got 2 here looking at that one as well. So that's 4, that's 2. This 7 looking at this square means that's a 3, that's a 3, that's a 7. This square's got to be a 5 or a 6 to complete row 5. Therefore that's a naked single. That's got to be a 7 just to complete the box. That 7 looks at the 7 and the 4. That's a 3 now. Therefore that's a 3 using the medium of madness, aka palindromes. Now, have we got this 4, 7? Is that fixable? Probably is, but I can't see how to do it. The 3 and the 2 at the top, though, we can put in. And therefore this is domino is a 5, 6 pair, which means that is a 4 or a 7, and maybe that resolves this square. We're looking for these 2 squares to add up to 9, so we can't use 7, 2, so we must be using 4 and 5. That fixes the 5, 6, fixes the 6, 5, fixes the 5, 6. Stunning. It's really stunning, this. 3, 7, 4, 1, 4, 7, 7 on the palindrome. There was probably other ways of doing that as well. And these 2 squares here have got to be 2 and 6, which we can't do, I don't think. Okay, but we might be able to tidy up some of these other positions now. We can't put 5s into those, we can't put 1s into those, we can't put 2s into these, we can't put, not sure. Oh look, no, there's a 5, 6 pair in that column though, so that fixes the bottom digit as a 1 anyway, so we get that digit. And we can rule 1 out of those 2 squares. In fact, what have we got in this 15 cage at the top? We've got 1, 3, 4 and 7. And we can take 1s out of here, 7 and 4 out of this side. So this is a 4, 7 pair. Oh, I was just about to say I've got a deadly pattern, but I haven't because of this beautiful palindrome here, which fixes it. 4, 7, 7, 4. Good. 3, 1. That can be done. So 1 in box 1 is now forced to be in 1 position. That's not a 2. So this is a 2. So this is a 2. 6 and 5 are done as a result of any number of things, including that palindrome, which I think I ignored. Okay, 6 disambiguates this, look, via the palindrome. Something, oh yeah, look, now I keep missing the palindromes. I'm so daft. Right, 5 and 6 go in there. 6, 2, 5, 2, 6. Probably done. Yay. Yay. Enjoyed that mightily. Not too difficult today. It really wasn't too difficult, but it was really elegant. I love the trick at the start where you could just basically, you can just basically use these cages to realize where, totals had to be in different columns, and it sort of worked its way around the grid with identical logic, giving us a whole sequence of 8s and 9s. And this 19 cage was clever because that had to have one of those high digits in it, and once we realized that, we could put all the 8s and 9s in the grid. I can't remember what we did after that, but it all felt very natural. It was just a very enjoyable Sudoku to solve. So I hope you managed to solve it. Let me know in the comments. I do enjoy reading them, especially when they're kind. And here's to a grand 2022 and a happy and healthy one to you all. See you later for another edition of Cracking the Cryptic.